Good morning, friends. Now we are discussing numericals on game theory using graphical method of module number 5 in the subject operation research. So whatever is the size of the matrix given, so whether it is 2 by n, that is only 2 rows of columns, or m by 2, m number of rows, 2 columns, whatever is the size of the matrix, so the matrix will be reduced to sub games, all the possible sub games. So here I have a problem on 2 rows and 3 columns. So divide the given game into sub games of the size 2 by 2. So here we are taking 1, 8, 3 and 6. So that is game number 1. Then 1, 8, 12, 2. So that is sub game number 2. Then we have 3, 6, 12, 2. So that is the sub game number 3. So that is the first step in the solution. So that is divide the given matrix, whether it is of 2 rows and n number of columns or m number of rows and 2 columns. So the given game should be divided into all the possible sub games of size 2 by 2. Now here player A is having only situations like do or die, only 2 options. So player B is having more than 2 options. Now the lines will be drawn here. A1, A2. 2 lines are drawn for the player A. Option 1, option 2. So do or die situation for player A. So A1, A2. So the first sub game is 1, 8. So row wise we are taking. So here 1 on line A1, 8 on line A2. So 1 and 8 will be joined. Then we have 3, 6. So 3 on the first line, 6 on the second line. So 3, 6 will be joined. Then 1, 8 is already drawn. The next line is 12, 2. So 12 on the first line, 2 on the second line. So 12, 2 will be joined. Now the situation do or die is for player A. So here we are going for the lower envelope where I am finding the maximum point. Maximum out of all the minimum values, that is the corner points here. So I am choosing the maximum one in the lower envelope. When it is for 2 by n, that is do or die situation for player A. If it is m by 2, that is only 2 options for player B. So then it is do or die situation for player B. Then the lines here will be drawn for B1 and B2. Then we are taking the values column wise. But now in this case it is taken row wise. That is A1, A2. If it is for B1 and B2, we are taking B1, B2. Okay, now for player A, taking the lowermost envelope and choose the maximum. Out of all the minimum score, A keeps the maximum one. That is the strategy giving the maximum score to him, leaving the other strategies. Now we have the maximum point P here, where I have the intersection of the lines. So that is 3, 6. So 3, 6 is taken. Then 12, 2. So 12, 2. So 3, 6 and 12, 2 are the two lines intersecting to give rise this point P. So 3, 6, 12, 2. 3, 6, 12, 2. So that means player B will keep these two strategies 2 and 3, discard the strategy 1. But A cannot discard any of the two strategies. So B1 will be eliminated. Value of the game. Using the formula, we are finding out value of the game. So we are getting 66 by 13. So we are getting the value 66 by 13, something like 5.1. So this is the baseline. So from the baseline, if you measure this height, it gives rise to same 5.1, which is the same value what we obtained using analytical method. If the game is played 13 times, the strategies, okay, here player B discard the first strategy, so here it is 0. Then we have 10 by 13, 3 by 13, or using the formulas. Or you can go for the shortcut as we described earlier. Then next problem. So here, so 2 options for player A, 3 options for player B. So divide the given game into sub games of size 2 by 2. 4 minus 1 minus 1 4. Then 4 minus 1 0 2. Then minus 1 4 0 2. So we have 3 sub games. Since it is 2 options for player A, do or die, so the lines are drawn for player A, A1, A2. If it is for player B, we will write B1, B2. So here also choosing lower envelope and choose the maxi min. So if it is for player B, we are going for the upper envelope and choosing the mini max. Player B wants to give minimum score to the winner. So in the upper envelope, we'll choose the lowermost point, that is mini max point. So now after checking the existence of saddle point, it is proved that no saddle point. So here we have value of the game and then the strategies. So in the lower envelope, choosing the maximum point. So value of the game is obtained as 8 by 7. So it is like 1.1. So from the base, if you measure the height of this point P, it also comes to 0.1, which is same as this 8 by 7. So these two lines, that is 0 comma minus 2, sorry, 0 comma plus 2, and then we have 4 minus 1. So in that given matrix, 4 minus 1, 0, 2 is retained, minus 1, 4 is eliminated. That is the second column is eliminated. B2 is eliminated. So 0 is there. Strategy player B. Thank you.